We are entering the world of calculus here as we conclude the pre-calc course. These are ideas that you're going to see in a full-blown calculus course. We're going to kind of just dip our toe into it here. Now, the first idea that we need to take a look at is the idea of a limit. And the idea of a limit is this. We want to know that what value a function takes on, so in other words, the value of y, as x approaches it. Now you say as it approaches it. Why would we want to say as it approaches it? Well, we're going to see some situations where the actual value of y doesn't exist. Now I'll get into that some more in just a little bit. But first of all, let me kind of sum up this point. Now you've heard me probably say this before in other videos. The mathematics is a language, like learning Japanese or Spanish. And what it's a language that does is it abbreviates. It's a language that if you speak it, you can turn a sentence or two of English into just one little mathematical statement. So here's what a limit is. I want to know what the value of a function is, the y value, as we get very close to a particular value. So our particular value here is going to be, we're going to call it a, but it could be any number. So as I'm getting close to 2, what happens to the function? Where is it going? Now, I guess it's a good time to kind of introduce why this would matter. Okay, suppose I had a function like this, where do you remember the idea of a discontinuity here? If I factor this denominator down, I would create this. Now, we would have asymptotes. In theory, we think we'd have asymptotes at 2 and negative 2. The denominator is not allowed to be 0 there, but do you remember a discontinuity would cancel those? I could reduce that and turn this into 1 over x plus 2. Now, even though this canceled out, we are still not allowed to have the value of 2 at any point in the function. So 2 is still not allowed, but what it's going to create is a hole in the graph. We're going to create a discontinuity at the value of x equals 2. Do you remember this? It would make just a circle. So at negative 2 we would have an asymptote, but at 2 we would have a circle. Because it canceled out, we called that a discontinuity. Now, even if you don't remember all that, you can still follow this idea. So what we'd want to say is, we might be interested in knowing, hey, where are we approaching when x is 2? And the reason we're interested in this is we can't actually find the value at 2 because the value at 2 doesn't exist. It can't happen at 2 because it has this hole. So we can never get there. But what I'd be interested in knowing is, well, I know it's not really there, but what would it be if it was? Or where's our graph approaching as we get there? Now, it'll make some more sense as we get into some more examples. I think this video will help have it make some sense. Now, I just gave you an example where we had a problem. We had a discontinuity down here and an asymptote. So this is a little more complicated. But if you look at this graph, 3x plus 5, that's a line. Now, there's nothing about that that's going to break, have any weird issues. It's just going to be a line. So if we said, hey, I want to know what's happening with the function as x is approaching the value of 2. You'd go, well, that's easy. All you got to do is put in the value of x, and I'll tell you where it's approaching. It's approaching 11. So if you put 2 into the function, you're going to get out 11. Now, we're approaching it. We're not actually reaching it, but we're headed toward 11, and that's all there is to it. No problem, right? Now, that was because it was as simple as it doesn't have any problems. Doesn't have any issues where it could break. So the same thing here. This function, x squared minus 2x squared minus 4, this doesn't break. It's a parabola. I don't know exactly what it looks like without digging into it a little bit, but it's a parabola stretched and shifted. Now, it doesn't break. It doesn't have any holes. It doesn't have any discontinuities. So if you said, hey, where is this function approaching when x is getting really, really close to 5? Well, all you got to do is put in 5. It doesn't break, so there's no issues. Now remember your order of operations here. This would be 25. We got 50 minus 4. And that's where the 46 is coming from. That's it. There's nothing else to it. Okay, but now here's the idea of a discontinuity. So this has a hole here. We can't just say that we can't ever get to the value of 7. So suppose we were saying, hey, what's happening here as x approaches 7? Well, we can't get to 7, so we're just going to have to talk about it as we get really close. If I get closer and closer and closer to the value of 7, where's this thing going? Now, we're going to need this idea too to help establish the big picture. We could also say, hey, what happens is if we approach x from the left? So what we do is just put a little negative. We're coming from the negative numbers and we're approaching the number 7. Well, we're going to say a little negative up there. We're approaching from the left. Well, as I approach from the left, the value of this function is 8, right? So its limit is 8. Now I can't get there, but it's approaching 7. I get a value of 8. That's where it's headed. And we could do the same thing from the other side. What about if x is approaching from the right, from the positive numbers as we approach 7? Well, the value of this limit is we're approaching from the positive numbers going this way. As we're approaching from the right, it's still approaching 8. So in both of these cases, the limit is 8. Okay, so that's what this is saying. So a left-handed limit is what's happening is we're coming from those negative numbers. So we're coming from the left, we say x is approaching from the negatives. Or we could say x is approaching from the right. Now, let me see if I've got a good graph here. Well, let me tell you this and then we'll say, it doesn't have to be, and hopefully we'll see this. Let me jump ahead. No, that doesn't have it. Yeah, let's look at this one. If you look here, what's going to happen is as we approach, suppose we were approaching 2 from the left. If we're approaching 2 from the left, we're going toward 8. But as we're approaching 2 from the right, like if we were coming on the function this way as we're approaching 2, we're not getting the same value. We're approaching the number 3. So whether you're coming from the left and the right may not be the same thing. That's why this matters. Now, if you have the same number, suppose you are approaching from the two directions and you're approaching the same number. So here's this number a. It's really 2 here, but suppose we're approaching 2 from the left. Our limit is going to be what, 1, 2, 3, 4, 5, 6. We're going to say that's approaching 7. So our limit would be 7. Now, as we're approaching 2 from the right, we're coming this way. It's still 7. Now we can't get there, but our limit is still 7. That's the number that we're approaching, the value of the function that we're headed toward. Now, here's the point. You can have these one-sided limits like this, which is perfectly fine. We're saying, hey, what's happening when you're coming from the left? Hey, what's happening when you're coming from the right? And if they're both the same number, then you just have the regular limit. So here's what we're saying. Here's the limit of this function. In every case, no matter what's happening, whether you're coming from the right or the left, this is where this function is approaching. Now, that is only true if you're coming from the left and the right and you get the same value. So what I'm saying here is you can have right-handed limits, you can have left-handed limits, and if they're the same, then we don't need to say right and left. We can just say this always has a true limit. Okay, now enough of me talking. Let's take a look at some of these. Hopefully it'll give you a hand. Now, let's take a look here. We've already kind of looked at this slide, but what is the limit of this function as we approach 2 from the left? Okay, so we're getting close. We can never get there, but as we're approaching from the left, do you see that our function is taking us up toward 8? Now, what's happening is we're approaching from the right. Well, we're heading this direction. We're heading toward 2, x of 2 from the right. And the y value that we're approaching is actually 3. We're heading towards a different place. You see we're heading toward this dot right here. Okay, now how about the limit as we approach 2? So we had a left-handed limit and a right-handed limit. Well, what about the limit as x is 2? Like just the general case, it's actually undefined. We don't have it. It would have had to have been the same from both directions, and it's not. So we don't have a limit as x approaches 2, because that means you have the same limit from the left and the right, and we don't. Okay, last thing here. They just want to say, what is the value of the function when x is 2? Well, it's 3. I'm just reading this off the graph. When x is 2, y is 3. Okay? Now, if a limit had existed, f of 2 here would have been the same thing as the limit, but it doesn't. So let's take a look at another one here. Okay, so let's take another picture here. We're going from another graph. We're going to 2 from the left. So we're heading toward 2 from the left. Now what's happening in the graph is I'm heading towards 2 from the left. I'm approaching a y value of 8. Now what's happening is I'm approaching 2 from the right. Okay, I'm headed, and I'm headed towards a y value of 8. So in this case, my left-handed limit and my right-handed limit are the same thing. And so my limit is simply 8 because they're the same from both directions. So I don't need to say right and left on this one. If this approaches 2, no matter how it approaches 2, it's always going to the number 8. And because, well, actually, this one is a little different. Our limits are approaching 8, but if you put 2 in for x, you're actually going to get 4. So here's a case where the limit and the value of the function at that point are not the same thing. So I didn't think about that, but that could happen. So we're coming from the left, we're going toward 8. We're coming from the right, we're approaching 8. That's where the graph is going. And so we can say there's a general limit at the value of 8. For this function, the limit is 8 as we approach 2. But the value of the function at 2 is actually someplace entirely different. It's down here at 4. And that's okay. Okay, now we've got one more. Now, I'd recommend you pause the video. I always say this. Pause the video and try this on your own if you want to. I'm going to talk us through this here. So, here's our first one. We're going to approach x, or we're going to approach 0 from the left side. Now, these are x values, so I'm approaching 0. Now, I'm following the graph approaching 0. Well, this is also, the y value is also approaching 0. Now let's come from the right. We're coming toward the right, we're coming toward the right, we're coming toward the right, and we're approaching a y value of 2. Okay, now as we are looking for the just general limit as x approaches 0, well, we were headed in 2 different directions from the different sides, so this doesn't exist. It doesn't have a limit because we don't have the same from both directions. So there is no general limit. We can say, oh, it always approaches this, because that's not true. It's headed in 2 different directions from the different sides. All right, let's try this one. As we're headed towards 2 from the left, so we're coming this way toward 2, heading toward 2. What happens is we are approaching a y value of -2. Now, how about 2 from the right side? So we're coming from the positives, heading down. We're heading down this hill. And we are headed toward a y value of 0. Now, how about a general limit? Well, once again, the left and the right don't match up, so there is no limit here. This doesn't exist. There is no limit. Okay, now let's jump down here. Let's try it again as we're approaching 4 from the left. As we're approaching 4 from the left, the y value is up here at 4. As we're approaching 4 from the right, the y value up here is also 4. And so we're headed in the same place. The limit from the left and right are the same thing, and so the general limit can be called 4 because it's the same from the right and the left. Okay, now I hope that's a good introduction for you on the idea of a limit. Math language doesn't make a lot of sense at first, but when you get the hang of it, it's summarizing the idea of, hey, what value of y are we approaching when x is doing this? Now, we don't have to get there. It's just what, as we get very, very, very close, what's happening. And all of that is summed up by that crazy notation.